All right, so in section 4.2, we're going to start looking at variation. So part one is all about standard deviation. All right, so we're going to start by looking at this first set of examples up here, where we're looking at a quality control department for a computer company. All right, so it says for a summer job, you're working in the quality control department of a computer company that manufactures computer parts. The specific part that you are to evaluate the quality of is supposed to be 8 micrometers in thickness. You obtained samples of 4 of these parts manufactured by the day shift and 4 parts manufactured by the night shift workers. Here are the findings. Okay, so for the day shift, you got 4 samples and they measured 7.9, 8, 8.2, and 8.3 micrometers. Okay, so what I want to do is calculate the mean and the median for these 4 computer parts. Okay, so let me pull out my calculator. All right, and this is a pretty small data set, so I'm just going to do this by hand. So for our mean, we're just going to add them up. And then divide by 4. All right, so the mean of this data set is 8.1. Okay. All right, so then the median, right, is the number that falls in the middle. So because we have an even number of data points, our median is going to be right in the middle between the 8 and the 8.2. So basically we need to average those two numbers together. So 8.8 plus 8.2 divided by 2 would give us 8.1 as the median. Okay, and I should point out here, oops, I should point out that these numbers were already in order. So that's why I was able to just go to the middle for that median. Okay. All right, now let's do the same thing for the night shift. So for our night shift, our 4 samples had thicknesses of 2, 4, 12, and 14 micrometers. So we can see that there's a much wider range of thicknesses from these night shift workers. So let's go ahead and find our mean of these. So again, we're going to add them up and divide by 4. So we got a mean of 8. Okay. All right, and then the median is again the number that's right in the middle. So with an even number again, we're looking halfway between 4 and 12. So I'm just going to do 4 plus 12 divided by 2, which gives me a median of 8. Okay. All right, so we can see that the day shift has a mean of 8.1 and a median of 8.1. The night shift has a mean of 8 and a median of 8. So this first question is asking us which shift's average was closer to the target. Well, if we're looking just at the averages, the night shift's average was closer to the target. Okay, but as you can see, just by looking at these numbers, there's obviously more to the story than just what the average is. So the second question here asks us, if you needed to use one of these parts on your own computer, on which shift would you prefer the part to have been manufactured? Okay, well, if we're just looking at the averages, then you might say the night shift because their average was closer. But if you look at the actual numbers, not a single one of these numbers was really even close to that 8 micrometers that we were looking for. Okay. Whereas if you look at the day shift, although their average was a little bit further off, all of the numbers themselves are really close to 8. Okay. So I would personally go with the day shift because their computer parts are a lot more consistent and each of them individually is going to be a lot closer to the 8 micrometers that we're looking for. Okay, so I would say I would choose the day shift because they are much more consistent. Okay, so although the night shift has an average that's closer to the actual goal, that's not the whole story. There's more information that you need to look at in order to figure out, well, which one's actually going to be better, which one's going to be more reliable in this case of looking for computer parts. Okay. All right, so number 3 says, in order to describe the variability of a set of data, a simple measure is to compute the range. Okay, so in statistical jargon, the range is the gap between the largest and the smallest value in the data set. Okay, so basically just subtracting the biggest number minus the smallest number. You want to pull your calculator back out. All right, so for the day shift, our largest number was 8.3. And our smallest number was 7.9. So that difference is only 0.4 for our range. Okay. Now the night shift, our largest number was 14 and our smallest number was 2, which gives us a range of 12. Okay. So again, that's kind of going along with what I was saying on part 2, that the day shift is just a lot more consistent. Okay, the range of their data points is less than half a micrometer, whereas the range of the night shift is 12 micrometers, which is more than just the size of the thing they were trying to build in the first place. So it's a really big range for that night shift. All right, number 4 says a more sophisticated way of describing the variability of a data set is based on the notion of deviation from the mean. Okay. For example, if the class average on a history test is 70, but you made a score of 87, your deviation would be plus 17 because you're 17 points above the mean. If your friend scored a 60 on the test, then their deviation would be a negative 10 because they're 10 points below the mean. Okay, we want to give the deviation from the mean for each part made on the night shift. Okay, so remember for our night shift, the mean was 8. Right, so if we look at each of these samples individually, okay, the first one, a 2, is 6 values below the mean, so that would be a negative 6. A 4 would be a negative 4, so that's 4 below the mean. A 12 would be a positive 4, so that's 4 above the mean. And then a 14 would be a positive 6 because that is 6 above the mean. All right. Okay, and then the last question here says, what properties do you notice about these deviations? And do you think these are true for all data sets or just certain types? Okay, well, the main thing that I notice here that I want to point out to you guys is that if you look at our deviations from the mean, we have a negative 6, we have a positive 6. We have a negative 4, we have a positive 4. Okay, now that in particular that you have, exactly the same or exact opposite, I guess I should say here, deviations on either side, that might be particular to this data set. But in particular, you'll notice that the main thing that happens from this is that when you add up all of those deviations, they're going to add to 0. Okay, so the sum of the deviations is 0. Okay, so that's the main thing that I want you guys to notice about those deviations there. Okay. All right, so a little bit of information. Okay. So it says the commonly used measure of variability is called the standard deviation, right? Supposedly, the standard deviation tells us the size of a typical deviation from the mean for a particular set of data. Okay. So here is how we're going to calculate the standard deviation. All right, step 1, find the mean. Okay. Step 2, find the deviation from the mean for each data value. Okay, so we already did steps 1 and 2 above. Step 3, square each of the deviations. Step 4, find the sum of all of these squared deviations. Step 5, divide the sum by the total number of data values, n, for a population, and n minus 1 for a sample. Okay, so in this case, this would be a sample because we just took 4 samples from this greater population of computer parts within this company. All right, and then 6, we are going to return to the units of the problem by taking the square root. Okay. All right. So for example here, okay, so we have our computer parts that we found above. Okay, we have our data, the 2, 4, 12, and 14, and we already found that our mean was 8, and we went through and we calculated the deviations. Okay, these are the same deviations that we just found above. And again, they made note here that the deviations add up to 0. Okay, that's something that you can check and make sure that you found your deviations correctly. All right, so then step 3 is square each of these deviations. So we would do a -6 squared. And remember, when you're squaring a negative number, you're doing a negative times a negative, which is always going to come out to a positive. So a -6 squared is equal to a positive 36. A -4 squared is equal to a positive 16. Positive 4 squared is equal to 16. And 6 squared is equal to 36. Okay. All right. So then, okay, so step 3 was square each of these deviations, right? Step 4, find the sum of all of these squared deviations. So we're going to add those numbers together. All right, so 36 plus 16 plus 16 plus 36. That gives us a total of 104. Okay, so the sum of these guys is 104. All right. So that was step, I lost track of where it was. Oh, step 4. Okay, so we're good there. All right, step 5, divide the sum by the total number of data values n for a population, or n minus 1 for a sample. Okay, and like I said, we're looking at a sample because we just picked 4 from our entire population. Okay. So we are going to take our 104 and divide it by, so n minus 1. So in this case, our n is 4 because we have 4 data points. 4 minus 1 would give us 3. So 104 divided by 3. Okay, and that gives us 34.67. Okay. All right, and then the last thing we want to do here then, right, it says return to the units of the problem by taking the square root. Okay, so finally, if we're looking for our sample standard deviation, we are going to take the square root of that number that we just found, the 34.67. All right, and actually, to be more accurate, you could just plug in the whole fraction so you don't have to worry about anything getting rounded, just to make sure that your answer is a little bit more accurate. So I'm going to go ahead and do that. So to get our square root, you hit the second button, and then you'll see this little x squared, your tiny little square root up at the top left corner of it. So right there. And then I'm going to type in the fraction, so 104 divided by 3. And that gives me a standard deviation of 5 point, let's just say 9. Okay, so remember that standard deviation is the typical deviation from the mean for this particular data set. Okay, all right. I'm going to go ahead and end this video here and pick up on number 6 in the next video.